I am testing a new system here for recording all of my, oh good. All right, I think we're good. So just testing a new system here for taking two sets of notes, one with the video and then one with my daily journal, so that I just, as I talk, I don't have to do it twice because it's getting to be a bit much. So this morning I actually did a little bit slight redesign on the casing for the screen, the microcontroller, and the second screen, and how that's done. It's just because of how this is built around here, it's just connecting USB drives and removing them is a little bit of a pain because of just how small the holes are. So just basically cut that section out and should be getting a new print here pretty soon. The other thing is I have moved on to phase 1C. So got a lot of things done yesterday that I'm really happy with. Got it so that it was detecting the drives, got it so that it was identifying which port the drive was connected to, and I also have a script now that will automatically program all of the ports for source or destination. So that's new. So now every time that I set up a new environment with a new like prototype or whatever, I can program those pretty easily just by connecting the drives, and it will just step me through that process and automatically give me the string that I need to match up with the port so that it knows where a USB drive is connected to it. So that's cool, got that working. And it is also maintaining the count so it can manage multiple source drives and multiple destination drives, and then it logs the order that they're connected in, and if you remove one, it automatically adjusts for that. It's storing that in a JSON structure right now. And so what I'm exploring for phase 1C is, do I keep that in a JSON structure, and for how long? Because eventually that information needs to go into probably a SQLite database, I think is the way that I'm going to move forward with it, because I want to be able to track performance information, drive information, all that stuff for my own testing partially, but also it could be a feature for the users eventually so that they can get all of their information. Like, wouldn't it be great to know how many drives you've processed this month, or how much data you've processed this month, or what tasks you ran and how many tasks you ran and how long did those tasks take? Being able to provide that information to the user I think would be cool. So being able to track that. Of course, there needs to be a way to prevent the system from recording drive information. If that's not something that the user wants stored, then just have that so that doesn't have to be switched on, or that that information gets discarded after it's done processing, because it needs some of that information initially to like process the drive, like what port the drive is associated with, the serial number for the port, and because there needs to be logs, and there needs to be obviously needs to know which drive to process. So that was kind of one of the important things that needs to be done. So how do you balance quickly getting drive information and storing it so that you can work with it as fast as possible, and then storing it for the long term? So that's what I'm trying to work out with right now with my engineering AI. I came up with a structure for a database. It seems like it's a little bit overly complicated right now for trying to get an initial product out. Certainly overcomplicated for trying to get an initial product out. So I'm gonna have to scale that back a little bit, but I at least want the structure to be in place so that I can expand on it later. So you connect a drive in, the metadata about that drive, some of it is static and some of it will be dynamic, some of it will be changing over time. But things like the manufacturer, the hardware serial number that's associated with the drive, that information won't change. But then you'll have partition information that will change, and then within the partition information you'll have file system information that will change. You could have multiple file systems on one partition table, and those could change over time. So you need to have like a table just for the drive metadata that doesn't change. So you have the drive instance, and then you'll have maybe multiple partition table instances. You'll have multiple file systems associated with multiple partitions, but all of those need to be tracked by a connection session. So like when you connect the drive, that creates one session, and everything gets documented for that session, for that drive, as it is found on the drive in that moment in time. And you may have multiple sessions with the same drive. So that all needs to be accounted for. And then if you select different tools and you run those tools, what tools get run with that particular session, with that particular drive, and then the performance data for that. So you may have a drive that you use as a source. You may have a drive that uses a destination. Let's say you've got a destination drive and you're using multiple source drives. How does the performance change over time? That'd be interesting. I mean, obviously the performance probably wouldn't change that much, but it would be interesting to see just how different source drives and the speed of those drives impacts the capability of the system. Similarly, if you're swapping out different destination drives, I don't know, but if we start tracking this stuff over time, I think we'll have some really interesting data that we can look through and figure out like what's going on with drive performance. We'll have, some real-time information to support that. So I think that'd be really cool. So that's what I've been working on now, and I just need to come up with a good plan for Phase 1C to see just, I don't even know that Phase 1C needs to be implemented. I don't know that there even needs to be a SQL database right now, but I at least need to structure the initial metadata collection, or as it does its assessment of the drive, so that it's easy to then store into a database. It'd probably be a hybrid approach, maybe initially just logging the drive, and then that will be that. Or maybe it's a smaller version of the database, the SQLite database, than everything out with all the performance metrics and everything. So that's what I'm working on now. And one of the things I tend to do is I lose sight of the things that are necessary for an MVP, and try to start adding in cool things. I'm like, oh, well, I could do this. Oh, well, what if it did this and this? And then the next thing I know, I'm a couple days into a project that nobody's going to pay for. So I need to keep that in mind. Will people pay for this, or is it critical to the user experience? And so that's kind of what I need to let drive me forward. So it seems like my document has stopped recording. I guess I just need to reset that from time to time. So I don't know what I got in my daily journal, but it's pretty close, I think. Either way, that's what we've got going on today. Another thing that now I'm talking to my document. Another thing that I spent some time on yesterday was building in the reliability of the communications between the microcontroller and the host system. So I was having some weird buffer issues where, it took me a while, and I was connecting drives, and eventually it would just lock up and nothing would work. What I found was there was a buffer on the 6th instance of connecting a drive. It would basically lock up the system. And actually it was the 11th instance of an action happening. So connect it, remove it, connect it, remove it. And then I think on the 11th instance, when it was no, we're done. So was able to get that resolved. And then I had some issues where that would work for a while, and then there would be this serial read error that would pop up after about 2 minutes. And once that popped up, and then I tried to connect or remove a drive, I get maybe 1 or 2, and then everything just locks up. And so I would kill the orchestrator, the host system, and then the microcontroller would start working again. And then I'd start it, and it would lock it up again right away. So was able to get that figured out and get that resolved so that it's now super robust, and it's responsive. It doesn't crash out. There was a series of basically buffer settings. It was basically an overflow of information getting into this buffer and then just locking everything up, or a couple of instances of that. And so clearing those out and then building in proper handlers for the data that's coming through, and also setting really slight send rate limitations on the host so that it doesn't overwhelm the microcontroller, which is has been unnoticeable to me so far. So all of that is awesome. Everything seems to be working well. I let it run all night, and I've just been connecting drives, switching on and off the Bluetooth. That's the thing that's working now, is you can enable and disable the Bluetooth. And as of now, with a day of testing and overnight, so there's some sustained time, it's been 100% accurate on and this is critical, obviously, but if the Bluetooth toggle is on or off, it is as it is on the system. So there's a redundancy check-in, you toggle it, and if it doesn't sync up on the system, then it flips the switch back. And every once in a while, you'll see that happen where you'll hit it, and it's too many commands too fast, and it toggles, and it jumps back. And it's all within maybe a second, but it's doing that confirmation to make sure everything executed properly, and it's not displaying information that is inaccurate. So that is really important to have, period. On the drive count, it's really quick as far as automatically detecting the drives. So I ended up using UDEV ADM for tracking that. It's kind of a hybrid system. So UDEV admin, then list block, and I can't remember what the other one was. There's a combination of those tools now, taking a hybrid approach for detecting the drive where it's constantly listing, but I don't have to, with LSBLK or fdisk, for example, you just have to check it every couple of seconds. There's a command, check it. But with UDEV, you're just basically waiting for the system to recognize new drives, and it's just a more efficient, effective way. So that basically triggers the system to know, hey, a drive's been added or removed, and then from there, other functions go in and other Go routines go in and pull out information about those drives and maintain the drive count, checks for source and destination. It's super effective there. It's really fast, and I can have a USB hub I've tested it with 4 different drives, and also a 5th one on one of the other ports, so 4 on the source, 1 on the destination. it queues up the drives that they're connected, so you're not going to have race conditions, and then it like adds those. So if you plug in 4 drives, it may take 2-3 seconds for it to recognize all those drives and put them in the queue, but you'll see them stacking up, going 1, 2, 3, 4, and the ticker going up as it's detecting them. So it's really quick, usually maybe 2 seconds for all 4 drives. And then when you disconnect it, it's like almost immediate. It's like, oh, 0 drives. And it's now reliable. So it's not locking up, accurately displaying how many drives are on which partition. How many drives are on which port and the use of that port. The next step will be ensuring that the source port is read-only, then figuring out how to track metadata about the drives. So once we have that, then we can move into adding in features like imaging. I think that's probably a good one to start with, wiping, or who knows what, but that's kind of when we move into the phase 2 of implementing feature, which is gonna be awesome. So I am super pumped. Stop again. So I am super pumped for what we've been able to do. I say we, like it's my team of AI and me, but I'm just really happy with where everything's at. And I cannot believe this timeline that we're living in. And Google just had their I.O. yesterday, or it's ongoing now, but the capabilities and some of the stuff that they've announced is just incredible. And it was weird because a couple days ago, I noticed Gemini really started, like, I don't know, it was yesterday, Gemini just really started working. So I don't know if they switched something on or what, but Claude decided it was going to take a dump on itself, and Gemini came in and just started working its magic. And then what I've been testing is having one system running Claude and another system running Gemini, my main system running whatever AI seems to be the most effective at the moment. But I'll have like Claude do a code review, and that was how I was able to solve some of the problems yesterday. Was Gemini was struggling. It was like trying different things and didn't seem like it had gotten to a good point, but it couldn't figure out why these serial read errors were happening and like what the next steps would be. So I had the code base thrown over to Claude and was like, hey, here's the problems I'm seeing. Can you do a code review and let me know what you think the problems are? And Claude came back and was like, oh yeah, I think I see the problem. Here are these potential buffer overruns, and here's how you solve them. And I took those suggestions, threw those back over to Gemini, and Gemini was like, oh yeah, okay, let's do this. Let's get this implemented. And it was within a couple of minutes that everything was working again. So there's definitely a place for having multiple AIs work on the same problem together. I'm still not giving up on the competition piece of it. I still want them competing with each other to see which one can solve the problem the fastest. So I need to get my systems set up a little bit better for that. I've got 3, maybe 4 that I should be having online. Really, I've just been using 2. It's been working well. I'm gonna need more space. Like, it's getting crowded. So anyways, that's where we're at today. Phase 1C. Let's see if we can get this done. See ya.